Hey, good day and welcome everyone. My name is Madhu Kotian. Me and my team are responsible for managing CRM, reporting, and related application. I'm also responsible for managing and maintaining our investment product system data.org. I've been with the company for 15 years, and prior to Northwestern Mutual, I was in different companies working on data architecture and data engineering. I'm also accompanied by my colleague here, Kyuri Shah, lead data engineer at Northwestern Mutual. Kyuri, quick intro.
Hello everyone, hope you all are having good time in the Spark Summit. I am Shah, engineer at Northwestern Mutual. I have been with Northwestern Mutual for past 10 years and part of various innovation projects. My most recent one was to move our field reporting BI space to big platform, and that's what we are going to talk about today.
We are excited to talk to you about Northwestern Mutual's journey to transform our BI and reporting space. In this talk, we will describe a journey to move hundreds of ETL jobs from our current MSBI stack to Databricks and build a data lake using Delta. Our approach for reducing our data load window. We'll also share our experience, our challenges, our learning architecture, and describe patterns used for undertaking this huge migration effort. We'll describe the data's different sets of tools and framework we used for ingestion and building a scheduling, which also in a way helped our engineers with their onboarding process. You will leave this session with some takeaways on what it would mean for you and your organization if you're thinking about migrating to AWS Spark and Databricks. Before we get through the agenda, quick overview on who we are, like who Northwestern Mutual is. So Northwestern Mutual is a 160-year-old Fortune 102 company that provides financial security to more than 4.6 million people. We deliver this through holistic approach that brings together a trusted advisor, a personalized financial plan that includes insurance and investment product, again, powered by technology to drive this seamless digital experience for our clients. Now, technology accelerates our business and the company strategy to deliver this digital experience to our client. It also helps our 10,000 plus financial representatives throughout the country to better serve our clients. Now, we have been in the digital journey or transformation for a couple of years, and the pace is accelerating more rapidly than ever before to meet the need of our consumers today. We are based in Milwaukee. Our headquarters is in Milwaukee with a strength of 4,600 plus employees. So these are the four pillars of Northwestern Mutual. I'll go really quick on this. When it comes to commitment to mutuality, Northwestern Mutual is a mutual company, meaning we aren't reporting any of the shareholder or Wall Street only to our policyholders and our beneficiaries. This allows us to plan for a long-term benefit for a client and think differently the way we manage the finances and investments. Financial strength is paramount for the value we provide to our policy owner. Now, again, this is affirmed by different rating agencies. We are only two companies in the US with the highest financial strength rating. Microsoft is the other. So when it comes to exclusive distribution, it really relates to our financial advisor. It's about providing this human-to-human interactions, which is more about building trust, while providing this financial advice to our policy owners. And all this is not possible if we don't provide best-in-class service and a long-term product value. That's a quick overview on what we do and what Northwestern Mutual is. Yeah, so what I'm going to do is quickly go through the agenda and then give an introduction about what our team does, or, what do we do from a reporting and a BI platform perspective. Kyuri is going to go through a quick overview of our before and after migration strategy. She's going to go through some of the framework approach. I'm going to come back and talk about the migration approach, what we did, and then key takeaways, the lesson learned. This is going to be something which you can take back to your respective organization if you are planning to transform your respective space into AWS and Databricks. So our team, like quick overview on our team. So this is a team of 30 plus engineers who are responsible for building, managing and reporting a platform that collects data from different heterogeneous sources, a disparate system. We collect the data, curate them. We do a lot of aggregation. We do also build a dimension model so that we can render this to report or dashboard needs. Our goal is to provide the scan and on-demand reports to different insights with different insights to our end users. We also work with different home office business partners like our in-house like NM users and provide them an environment to perform this ad hoc analysis. Now that's pretty high level on what our team does. So let's hear our world before migration from Kiwi.
So, what was our role before migration here? Like Madhu said, we are a reporting platform. We get data from all different kind of sources across NM. We get data from almost 30 to 40 different databases, which are all different from UDP to MySQL to SQL Server. Also ingest a lot of flat files in terms of XML files, CSV files. So over to the left, in the big picture here, we can see all the different data sources we get from our on-prem system and our cloud systems. Before migration, we used to use SSIS, integration services, and ingest and curate all of our data. Once the data is curated, we store them over to our next layer here, which is the data storage. And we used to use analysis services and SQL databases in Azure to store all of our data. Our data size is almost 2 to 3 terabytes at that point in time. And from there, we use Power BI and SSRS to do our visualization here. So a very typical MSBI, Microsoft MSBI stack we used. Now, a few quick stats before how would we be before? So we had almost 300 ETLs in our SSIS that we used to run overnight. It used to run for approximately 7 hours nightly. Any new feature that we would get, it would take around 5 to 6 weeks to put it out to the market, which means the time we get a requirement, on an average, we have to get new tables, curate them, put it into Power BI, SSRS, and then we ship it out to our production and to our end users. So that time period was approximately 5 to 6 weeks, which was a long time for our product and our business to wait. So tagging on to that, what were our pain points in our before infrastructure or our data space? Well, everybody in the organization and even at your organization, at your team level, you would have seen this trend in increased data volume. So just with increase in the granularity of the data that's available, increase in more data available, we have to start ingesting all of this new data because our business wants different reports, different analytics out of this huge, humongous data. Well, with increase in data volume, we increase our latency. So when we started, we were running at 2 hours of batch cycle. Well, we kept on growing and growing and growing, and now we were at 7 to 8 hours of batch cycle. And it's going to keep growing. We are not stopping here. So it's a straight linear latency. Like our latency increases with the new data load. Also with that, what increased was our data inconsistency and data sprawl. We had to duplicate data at different places. Like most of the industry standards, we have a reporting database, we have a data warehouse, we have a data for analytics use, we have a database for APIs. Because of all of that, there is an increase in data redundancy. And that adds on to all different kind of problems, saying when data doesn't match another and things like that. Another biggest pain point from our consumption standpoint was for our analysts. Our business users, our analysts did not have integrated data to work with. So as part of their analysis, what they had to do was they had to bring data from all of these different databases at one place and then start doing their analysis. It wasn't the ideal place for them to do their job. And then, of course, with increase in all of this, it increases cost. More database increase in costs, more compute increase in cost. Another main reason was because we were typical data warehouse with increased storage, we had to increase our compute too. So the cost keeps on growing exponentially here. And then security. As a financial company, security is at most important to us. It was just getting challenging to manage that highest level of security with all other problems that we were going on. So keeping this in mind, we decided that it was a time to move to a more modern, more scalable, more secure platform. So when we decided to move to a new platform, what were our different considerations? Well, our bread and butter, how do we do ELT and how do we schedule all of our jobs? Performance, that was a major thing that we were looking for. Like I said, 7 hours and it kept growing. That was not at all ideal. Second important thing was any new tool we use should be easy to maintain, easy to use, and easy to learn. We wouldn't want any developer to go through intensive 1 year, 2 years worth of training and then start contributing. In our agile world, we had to pivot quickly, we had to learn quickly, and we still had to keep producing our business results. Um, One another main consideration was when we compute our scale, when we scale our compute and our storage, we want to manage our costs accordingly. So we keep on getting more data doesn't mean our cost has to increase exponentially. And then, like I said, we had a lot of complicated dependency. We get data from 30 to 40 different sources. And managing complexity at a table level, at a job level, it just becomes a huge spider web at this point in time. Well, that's not something we can avoid, but what we wanted to do is make it simplistic for our developers to put those complexities in place. And for anybody who's debugging, make it easier for them to understand all of these complicated dependencies. So moving on to the middle here, our data lake, our storage, that's another main pillar when we talk about our new platform. Our data lake had to be governed. So every metadata we put in, a new table, a new column, changing column, all of that had to go through a good governance process. We have so many downstream consumers that use our data. We don't want them to come down while we are making or improving our system. So that was an important factor when we consider our new platform. Support asset operations, typical insert, create, updates, delete, all those should be possible at a table level. Ability to look at the past data. What that really means is, well, I am every night we do a nightly jog, but we also want to go back past 3 days, 4 days, and see what was the state of our data at that point in time. It's important when we try to do time bound reporting and things like that. And then data validations and data quality. Every night when we load our data, next morning when our users, our field users comes and logs into their report, we want to make sure that the data that they are receiving is of the highest quality. So moving on to our third pillar here, security. As you all can see, it has a section on its own, which means it's of utmost important. While we do encryption at rest, encryption in transit with all of our implementation, column level encryption is a major requirement to protect our PII and PHI information. We don't just want to protect it against hackers, but we also want to protect it from all of the people that's accessing our data, developers, testers, analysts, admins, only those people who are authorized to see the PII, PHI data should be able to see it. And that kind of moves me to our next point, which is role-based access to databases, tables, and views. We want to manage who gets access to what data easily, which means one group can get access to a certain set of views, another group can get access to another set of views. And everything should be Active Directory enabled and Active Directory controlled. Azure Active Directory is one of the major grouping how we do at our organization at all different levels. So it's very important that it has the whatever tool we choose has the capability to integrate with Active Directory. So while doing those considerations, I want you guys to take a quick look at what does our world after migration looks like. Well, obviously on the left, our sources did not change. Another decision what we made on our right, our visualization layer did not change. So how our reports Power BI were rendering, SSRS reports were rendering, nothing on that changed. What changed is our middle box here. Instead of ingesting data through SSIS, we are now using Databricks and Airflow for scheduling. We have built we have built custom frameworks on top of our Databricks and Airflow to make sure like everything is easy to use and easy to manage for our team, for our organization. And for data storage, instead of SQL Server, we moved all of our data to a data lake and we use Delta tables. Delta table supports all the ACID operations, time travels, which was the features that we were all looking for in our data lake. We also have a MySQL instance, which we manage for our high concurrency, low latency use case. Well, a quick stats in the same compared to our before slide, how did we do after our migration? So instead of ETL files, now we are counting the config files. And we can go through in little bit detail what does that mean. But we are now over 500 plus config files in our frameworks. A huge difference what we saw with our batch cycle times. Instead of taking 7 hours, it now takes only 2 hours. And minded, we are now ingesting more data than we used to do before. We made some changes in our ELT because there was always need for more data. But now that we can ingest it with more data, our cycle time came down. So that was a huge win. Um, Another quick set time to market. We used to take approximately 5 to 6 weeks for average level requirement, which now drastically reduced down to 1 to 2 weeks with all the approvals, with all the CI/CD processes we put in, just by the nature of tools and technology, we can now put new requirements in for 1 to 2 weeks. So that was a amazing change. But how did we do all of this? So, like I touched a little bit on the previous slide, the config files, what does that really mean? We built various development frameworks to help facilitate our developers. First of them is our ELT framework. It sits top on our Databricks and uses Python PySpark, but it basically what it is, it takes some config files. They are simple to read, simple to apply JSON files. It has different options like you are trying to read from a DB2 database versus you are trying to read from a CSV files that developers can put in, and the destination level. How do you want this curated data to be placed at? So that helps our developer not write any complicated PySpark for every ETL. Every ETL now basically gets converted to a config files, which developers check in. It really makes it simple to use, not only developers level, but even from support perspective and debugging perspective, we basically go in there and we use these JSON files. It's also CI/CD approved, so that helps with the approvals and all. Another thing important what we have put in our framework is column level encryption. So how we identify our PAI PHI columns, and then the framework takes care of encrypting at column level. Yesterday there was a talk uh, on the same topic. So if you guys are interested, please watch the recording on it. Moving to the middle here on the metadata framework, pretty much same philosophy. It uses a config-driven YAML file this time, but it's basically schema you provide, column names, databases names, access request everything through a config file, and then the framework goes in and takes care of creating all the databases automatically, creating all the views, making sure applying all the access controls, all of that. So there's a talk schedule today at from 5 to 5:30. If you guys are interested, please join us. And then similar lines over to our Airflow framework. Like I said, we have a very complicated dependency management, and we didn't want our developers to write hundreds and hundred lines of code to manage all the dependency at every table level. So we abstracted all of that out to a config file. So now what developers have to do is put a schedule, put all the dependencies for the table, and then the framework takes care of creating a tag at an airflow level. If anybody has more interest in knowing what that does or how it does, feel free to connect with us on LinkedIn and we can get together and get more information for that. Now, how did we do all of this? So I will hand it over to Madhu to talk about our migration approach here.
So when it came to our migration approach, the first thing was looking at the team setup. So we started with a small group. You may all have different Scrum teams to manage your respective data analytical platform and manage different business priorities. What we did in this case was pulled a couple of engineers from different teams, our Scrum teams, to form this cohort group. We provided a sense of autonomy to them to perform these incremental experiments in POC and incrementally mature the platform capability. The key here is to use your existing skill set, existing team, because they understand the business rules and the logic behind it. Bringing someone from external, you can work through it, but sometimes it can delay your progress. So that was a learning here. With respect to code migration, when we talk about incrementally maturing the platform capability, we started with one end-to-end flow with an intent to make it production ready. This gave us an opportunity to enhance our framework as we moved along. So it gave us a good view around what that end-to-end view looks like and what the shortcoming of the frameworks were. So we incrementally improved it as we moved along. Also, for our migration, we did not consider lift and shift, and we did not use any of the accelerators to fast track the project. Now, there is benefit of using accelerator. In our case, we had a lot of redundancy in our model, in our ingestion process. So we wanted to relook at all that, relook at the entire structure, and then build everything new. So that's the reason we ended up not taking accelerated, because that would have basically taken us back a little bit in terms of our timeline. Now, when it came to the experience, Kiri touched on that. We did not change our reporting and dashboard layer. Our goal was not to impact our end user experience. We eliminated the dependency of the MSBI infrastructure application had and moved the scheduling and data ingestion and the backend infrastructure. So without impacting the front end aspect. So pretty much changing everything behind the scene. So that's what we did. So in essence, our end users basically were oblivious of all the change happening on the back end. Now, from a validation and a support perspective, um, we had the option to keep our Azure environment up and running while we were incrementally building our AWS environment. This way, you can go about building continuously your AWS structure, but you can also at the same time validate the data and compare what you see in AWS. So that way, you can match the parity between them and see what's missing. Now, if you remember me talking about incremental build, with each incremental build, with the validation and verification place, we also push the feature out to our user for any feedback on performance or data quality. So when it came to key takeaway, something you can gather from our experience here, the first thing we looked at was a first priority actually was to look at business product and security need. We approached our business with this idea. So obviously for them, they should be on the same page around what this really means to them. There should be a common understanding on the pain points we are trying to address. So we ended up working with them, understand their pain points. So as you know, from a business perspective, there are numerous pain points when they are trying to deal with different data needs. They worry about timely data. They worry about the data quality. They have different ad hoc analysis and need. So obviously they don't get access to those different production system, it's very restrictive. They end up building their own shadow IT, bring all the data together in their own environment. So in essence, it becomes stale. The version of truth is not accurate. So there are numerous pain points the business team has been running with. So we basically captured those pain points. It was a good input for our business case as we built the justification around why we want to really migrate to this new platform. Other critical thing we did upfront was security. Again, this was something Curie touched on. Security is first class citizen. NM being a financial company, we are subject to numerous audits and security reviews. So we made sure that a solution architecture wise, we have everything in place from an encryption perspective. So we wanted to make sure encryption in transit, at rest, and even column level encryption to protect the PI and PHI information. And that was basically one is implementing the process and how do we really promote access to different users to come in the system. My philosophy overall is not to restrict people from getting the access, but you can restrict around what they can see. So if you don't want them to see PI, PH information, you can put specific controls around it. So it's more about democratizing the data, having that available to anyone who wants to consume it. So for us, for us, the key was to make sure these security controls are built into the framework. So before we venture into any POC or work around building the framework, we wanted to make sure those security controls are in place. Now, from a product perspective, we do have along with business, we have digital product partners we work with, and the goal is to meet those business priority. Now, by carving, and they worry about the velocity of the team. So by carving out the team's velocity upfront to work on this feature step was very critical for us. So as we confirmed on the experience, we were quickly able to onboard the rest of the team and adjust their velocity, take on additional innovation work, plus deliver on some business priority. So that's what we did with our business product and security team. The other aspect is also showing and proving your progress. So as you're incrementally learning through the process, deploy this incremental chunk and get immediate feedback from our stakeholders. Also, communicate. I think communication is very critical, cannot stress enough. Don't use this as your secret project, right? You're innovating, don't use, like, you don't want to share with many people, but I would say share it, because you will be surprised to get a fair amount of feedback from them, which can in the end benefit your product. The other aspect is the other thing we did very right was the plan to onboard our engineers. So as we looked at the reason why we built the framework, all our developers are MSBI stack engineers. Now again, it's overwhelming for them to really venture into Python, Spark, and Databricks, and with an intent to deliver everything in a year and a half. So it's a daunting task. So it would have been a huge lift for them, actually. So building the framework was very critical for them, because one is they can understand from a data engineering perspective what is needed, and the framework gave them a path where they can use this config-driven approach, and then in the end also use this SQL knowledge in transforming into this new platform. So we were very meticulous in the training program around what we want our engineers to learn. So we developed them the Python, some sort of Python beginners training, the how-to guides. We created some sort of a workshop so that they can navigate through the process and understand what those pitfalls are, and then they can learn from it. And plus, I think the beauty was, since we carved out this separate team to work on it, they were basically sent back to their individual team, and they were basically the mentors of rest of the team as they were onboarding. As I mentioned earlier, we kept our feedback, the fallback option open, which is Azure, so that if we have to ever had like a scenario where AWS was not working as we expect, we always had an option to revert back and move to Azure. We didn't have to do that, but it was a good validation for us. The other key point here is, you may think that you're working on a cool new technology, leveraging the power of distributed computing, but your downstream system is not ready for you. Please consider them and consider using appropriate amount of cluster when you're hitting your downstream legacy system. You can bring them down. We did it. but we quickly recovered, and we that was a big aha and a learning moment for us. And we ended up basically optimizing what level of cluster we need to open when we are hitting the downstream system. So this is pretty much a talk. In closing, we are not done here. This is just the beginning of a journey. We are working on setting up our E2 instances, and I can't wait for our business to put their hands on SQL Analytics and build on the Lakehouse pattern. I hope the journey we shared here in our presentation today was insightful, and hope this can benefit your journey ahead. Thank you for all listening in, um, and looking forward for any answer questions you may have. We can answer those. Thank you.